welcome to December Lead Coding Challenge Day 5. So today's problem is called Can Place Flowers. You have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. So you'll be given an integer array of ones and zeros representing the existing state of a flower bed, and another integer n, which is the number of flowers that we want to place. You need to return true or false based on whether you can plant n more flowers. The key here is that the flowers cannot be planted in adjacent plots. So this is another simple problem today. Monthly challenges tend to be very lenient on the first week. So if you want to pause the video right now and try it out, please go for it. The problem basically boils down to two things. We have an integer array of zeros and ones such that there are no ones adjacent to each other. We need to place n more ones in this array such that there are no ones adjacent to each other. If this is possible, we need to return true, otherwise we return false. This is very straightforward. First of all, if n is 0, it's definitely possible to place 0 flowers, so we can return true. If n is not 0, we need to iterate through the flower bed and make sure we have enough zeros that can be converted to ones. However, we cannot count the zeros that have an adjacent one. So we need every zero that doesn't have a one to its left or to its right. Be careful about the left extreme and the right extreme. Once we have a count that is greater than or equal to n, we can return true right away. At the end of this loop, we can simply return false. The space complexity of the solution will be O of 1. The time complexity will be O of n. Length of the flower bed is at most 2 times 10 raised to 4, which means O of n will do fine. Now let's try to code the solution. We'll keep track of the count of valid zeros that can be converted to ones in a variable count. The length of the flower bed can be set to a variable len. This is for easy access. Now we can iterate through the flower bed. We're interested in counting these zeros, so let's write a condition for flower bed of I equals 0. Inside it, we can increment count and check whether count is greater than or equal to n. Now we need to make sure we are only counting zeros that don't have a 1 to its left or to its right. So we can try this. We need to also handle the scenario when I could be pointing to the first or the last element. Just need to check if I equals 0 and I equals len minus 1 for the left and right conditions respectively. Also make sure to set flower bed I equals 1. This will ensure that the next adjacent zero will consider its left element 1 and not 0. At the end of our loop, we'll just return false. Hope you enjoyed this video. If you did, please consider subscribing. See you soon.